Before we can start to find the nth derivative of f of x in example 4, I just want to explore factorial notation a little further. Do you remember I said to you that if I wrote 5 factorial, that's the same as having 5 times by 4 times by 3 times by 2 and times by 1, where 1 was my smallest factor. But how could I have used factorial notation if I just wanted 5 times by 4? I'm going to show you by doing a manipulation, and the manipulation I'm going to do in green. If I times 5 times 4 by 3 and 2 and 1, both in my numerator and in my denominator, you can see that I have developed my factorial notation. In my numerator, I actually have 5 factorial. In my denominator, I've got 3 factorial. So in fact, I could have written this as 5 factorial in my numerator, and in my denominator, I had 5 minus the 2 factors that I wanted of 5 and 4, which gives me the 3 factorial. This information is going to be critical in moving on. Also remember that I cannot have a number, for example, like minus 3 factorial, because my smallest factor is the factor of 1, and minus 3 is smaller than 1, so that is impossible. So now if we want to find the nth derivative of f of x, remember we have to start with the first derivative. The first derivative is going to be the derivative of the composite function, and so that is going to be 100 times by the bracket of 3 minus x to the 100 minus 1, which is 99, and times by the derivative of the inner function of minus 1. Now when I go on to find the second derivative, remember, we don't simplify the first derivative, so I'm going to leave all my factors exactly as they are. Now finding the second derivative, remember the critical part is the part with the variable, and that is still a composite function. So 100 was just a coefficient, and that needs to be times by 99. The bracket, 99 minus 1. I had a minus 1, and I've got to times that by minus 1, which is the derivative of 3 minus x. When I get onto my third derivative, it's starting to look a little complicated, and so once again I'm going to highlight in yellow the part that has the variable, which is critical to finding the derivative. Remember, all the other numbers are just constant coefficients. So now if I find the third derivative of f of x, I'm going to have 100 times by 99. At the back, my coefficients are minus 1 and minus 1. I must now find the derivative of the bracket raised to the exponent 98, which gives me 98 times by the bracket to the 97, and that must still be times by the derivative of 3 minus x, which is minus 1. Let's go on and find the fourth derivative and see if we can find our pattern developing further. Highlighting the part that's essential again, which is the part with my variable, and the variable is the variable x, I write down all the other constant coefficients. 100 times by 99 times by 98. At the back, I had minus 1 times by minus 1 times by minus 1. Now working with the part highlighted in yellow. The derivative is going to be 97 times by 3 minus x to the 96, and then times by minus 1. Now before I get on to finding my nth derivative, I'm going to see if I can create a pattern using the fourth derivative number. Remember, we always try and make a link between the expression and the number of the derivative. So if I write the fourth derivative of f of x, I could have written this as 100 factorial. Now if I wanted just 100 times 99 times 98 times 97, I would have had to divide that by the factors that I didn't want. And the factors that I didn't want were 100 minus the 4 factors that I did want, which gives me 96 factorial. Now that I've sorted out a pattern for those first 4 constants, I'm now going to look at the bracket. 3 minus x is raised to the 96. How can I write 96 using the number 4, which is the derivative number? Well, 96 is the answer when I say 100 minus 4. Then lastly, if I go to my minus 1's, I have got 4 minus 1 factors. If I highlight for you to show you what I have done, I've taken this number 4, I've used it here, and here, and here. Now I'm ready to write out my nth derivative. So the nth derivative, f nx, is going to be 100 factorial all over. Remember, where I had a 4, I'm now going to write an n. So now I've got 100 minus n, all factorial. Then my bracket, 3 minus x, and that's 100 minus n, times by minus 1, all to the n. Well, that was seemingly very painless. There's just one more thing I want you to notice. Can you see that you have an n in your 100 minus n factorial in the denominator? We're going to have a look at that and just see, are there any restrictions? In order to understand our restrictions, I'm just going to have a look at that n in the factorial bracket. What would have happened if I had 100 minus 100, all factorial? Well, that's equal to 0 factorial, and we know that that number is 1. So we're safe up to 100. But what would happen if I said 100 minus 101 factorial? Well, that gives me minus 1 factorial, and we know that that can't exist because the smallest number must always be the factor of 1. In other words, for the nth derivative of f of x, I must have that when n is an element of the natural numbers, a counting number, n also had to be smaller or equal to 100.